Always.
How's it going?
Good. It's just a little crazy, but yeah.
Yeah. Okay.
Whoa.
Do we have any questions about Abacus? How's it going?
I was wondering if we can continue with what we had last week.
Yes, I was just about to find it because I did work through those questions. Like, okay. I just gotta find it. Can we do it here? Here. Okay. So the first one was I think I did it here. Oh, that's right. It was I apologize. It was the algorithms, right?
Let me know if that gets louder.
No, I cannot hear her.
Oh,
You don't think
man.
it was the algorithm?
Let's see. That's her. Let's see.
Okay. Let me know if it goes down or up.
She's not talking. Let's see.
Okay, well, can I quickly print my thing?
Let's see. Okay, let's start off with that was the picture, that was the addition, and then example. Okay. Are we okay? Okay, so remember there was that one printout with the example? With the tens and the ones. Let me see if I can find it.
Yeah, you can look through that.
Right. So it was share. There we go.
Change it. It's going to go front to back.
Let's do that. Okay, so can you see my screen?
Yes, I can.
Oh, that's the wrong one.
I see lots of things.
Yeah, that's still the wrong one. There we go.
Yep, there we
All
go.
right, here we go. Let me move everything back out the other way. There we go. Okay. So, so we had the bars. Did it make sense where the bars are going?
Yes, it did. After you, because I went over and I read it, and then after you explained it to me, basically what you're saying is that in the ones place that they are creating 12, and then they circle pretty much 10
Oh,
from
yeah,
the 12,
right,
bring it over to the tens place.
right. And in us, what we do is we make the 10, and then because we make the 10, then we have something left over. So it's easier for us to see on the abacus.
Mm-hmm.
Yeah, I thought that was a really good find. That was really good. And then we continued on with so that's why it's different, depending on the add-in. It always depends on the second number. So that the second number, right, there's the 3 over here. I don't know if you
Mm-hmm.
can see my screen. Let me see if I can annotate. It's always the second number over here that tells us what we're going to do. So just as we had before, you uh to make so that's the thing. So to make the 4 a 10, right? We need to grab this information and put something here. That's what we're doing.
For the
Does that
abacus? For
for the
abacus?
abacus? Yeah, for the abacus.
Oh yeah, because we have to do plus the 10 minus the 6.
Yeah. So, oh, sorry, that's the 10 over here. And then what we're going to do is we need to add 6 here, but to add the 6, we have to minus from here.
Yeah. And with her group of ones, because she has it grouped in 8 and 4,
Yes, she
you
puts it all
have,
together.
yeah, you have to, if you were to subtract, with the ones there, that that that's a little bit more confusing with what she has there, because I think the whole purpose is to add the 8 and take 2 away from there, in the picture.
Oh, yeah, you think so? I don't know. I have
Uh-huh.
to look. Okay. So that's interesting. Oh, I need to clear all users. There it is. So she has it here, and then, oh yeah, I see what you're saying. I see what you're saying.
Mhm.
Yeah. So she makes the 10 in the first one. Yeah, okay.
Yes. And then you have a remainder of 2.
Yeah,
And
I
that's
could see
why,
that.
so you have the 2, and then you carry over that 10 in the tens place.
Yeah, I see. Mm, I guess. I
I mean,
guess.
the whole purpose is to make sure it's easier to add from 10 than it
True.
is. And so what she has there is not bad.
No,
Um,
not bad. It's different.
it's different.
Yeah, because it's choosing the number to make it the most, choosing the highest number to make it the easiest, which
Yes.
is which is interesting, which is interesting because what happens? when there's more numbers. See, right now it's only 2 lines. So 48 plus 30, 34. Then when you have another, let's say we did all here. Oh, I see. Because they do ones first.
Yes.
They don't do it as a group. They don't do it as a whole.
No.
Yeah, okay. Yeah, it's been a while since I've done like regular math, mainstream math.
Regular math. Yeah.
Yeah, because for abacus we do a running total. We do it this way, and then we do this,
Hmm.
and then we do that. If we were to add that total. Okay.
Right.
So that was that one. And then the other one was explaining. Let me see if I can get out of this. Nope. The other one was her algorithms.
Yes.
So, but it's kind of the same because what they're doing is they're adding all of the digits. So they're growing up to 12. So they start with the ones place and it doesn't matter if it's 10. It just spills over. So you never go up to 20, but you only go up to uh, 18, really. If you
But
think about it.
in the ones place, she's saying, is the sum greater than 9? So
Yeah,
if no, then I don't know what
trade.
record your work, but you basically add it, is what she's saying. Record your work. You record, you write,
You write it out.
you
Yeah.
write it out. But if it is greater, then you trade. So an example would be, here, show an example.
Yeah. Yeah.
12 plus 8.
Yeah. So stop. And then I'm going to can I do that? Okay, good. Okay. So funny, anything higher than let's see, anything higher than the way she wrote it, right? She says anything higher than 9, that means 10, 11, 12, 13. Oh, can't see that. Hold on. Yeah. So what she's talking about is anything higher than 9. So not equal to 9. It has to be higher than 9. So yes,
The sum, anything that's greater than the sum of 9.
yeah. So yeah, exactly. So it was like what? Let's do 8 plus 5, right? 8 plus
Mm-hmm.
5 is 13. Because how do I
Mm-hmm.
know? I have 8 and then plus the 10 minus the 5. Oh, sorry.
Mm-hmm.
Right. So what she was saying is 13. And then whatever this is, she wants you to already combine it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have this. So when she's talking about it, I'm assuming it's a she.
Yeah, she.
Okay. So I'm assuming that anything greater, you still combine it and then you have to trade. That's how I see it.
You trade 10 in for a 1.
You trade 10 in for a 10.
Yeah, 10 ones for 1
Yes,
rod.
correct.
And
But she's still
so,
counting up to 13.
okay,
Whereas,
because she's adding 5 and she's counting from 8
yes,
and adding 5.
yes,
Okay.
yeah. But whereas on the abacus, we don't need to count all the way to 13 because we're not counting up. We're doing a concept. We're doing an exchange.
So
Right.
the exchange that we do in the abacus, that's not the same as the trade-in that she's doing?
No, the like technically what technically if we did this is equal to 5, what we're doing is we're trying to add 5 to equal to 10. We have to
Mm-hmm.
take away the 5 from here, right? And move it down here.
You lost me a little bit.
Wait a minute. Oh yeah. Okay. So I'm trying to workshop this one out. I'm almost got it, but I think it's kind of because we got to take the information from here. So we have their 8. And what we're doing is we're trading in. So their trade is we already know we're going to make a 10. We don't need to do the extra work of figuring out how to take away, how to add the 2 more. Because what we're doing is we have 1, 2, 8, right? We have 8. And this is 5, right? So what we're doing is we're taking this information and we're putting it here. So we're taking the 8 and we take the 5 from the 8 and we add it to here. And then this is the trading in that we're doing. So we add the 10 over here, but we have to minus it from the 8.
Leave him alone.
Oh, yes. Oh, yes, yes.
That's what we're doing.
Okay.
We're taking it from 8 and we push it down because it's always the second number that dictates what we're doing.
Yes.
We
Leave him alone.
don't do, so you know how in mainstream math we do right to left, and I said we could do right left to right. That's fine, right? To go if we have more digits. So if we have 34, 5 plus 8, 7, 6, right? It doesn't matter if we go left to right, right to left. But it does matter when you take from the first digit to the second digit, because that changes. It's always going to be this. It's always going to be the number coming into it. We always look at this number that we're trying to do, not this number. So the way she has it is, oh, it can be interchangeable, but we don't do that, because what do is we don't do 8. I'm sorry. 1 plus 8 is equal to 10. We don't, or equal to 9. We don't do 8 plus 1 is equal to 9, because this is what dictates what we're trying to do.
Yep. Because, yeah, because that determines whether you're going to be adding or minusing a 5 or plus or minusing a 10.
Right. So I was watching some other teachers that they were trying to teach, and what I noticed is they're like, "Well, we have to memorize our math fact at how to make a 9," and I'm like, "Why?" Because if we look, we have 1, and is there enough to add the 8? Yes, add the 8. And then it's again, if I want to add the 2, do I have enough to add the 2? Yes, just add the 2. So for Abacus, we don't need to, this is not a math fact for us.
Well, it's simple math, and plus you're the abacus is there to help you visually see what you're adding and what you're subtracting, so you don't have to do any memorization there at all.
Yeah, exactly. The only fundamental that we need to do is making sure that we know how to add the 5 and add the 10. Those are the only memorization that we need to do for us. As long as you know how to do these 2, then you're set.
Okay.
Right. That's why I always go back to how do we make the 10 and how do we make the 5? And I know, like, the concept, obviously the concept is different because mainstream talks about it. And that's the other thing. Mainstream, there's no structure. They're just like, just memorize it. It's like, wait, no. I mean, you can logically think, like, what are we trying to do here? We're going to add the 5. Yeah. So that, I think that's what I would have to do is 1, 2, 3, 4, 5, 6, 7. Yeah. So then this would be the number, right?
Mm-hmm.
So we have 8 on the abacus. Right. And that's what we do is we take the 5 from the 8. We take this 5 and we give it to this 5 to make a 10. So then we do that trade.
Yes, that does make sense.
Yeah. So that's what she was saying there, and that's the difference between what we're trying to do.
So her algorithm for the subtraction, what is she basically saying there? Because
Algorithm.
there was
Yep.
there was the one for the subtraction as well.
Yep. Hold on. Let me see if I can find it. There we go. So oh, sorry. There. Okay. I'm in the wrong one. Okay. Oh, there we are. So the subtraction one, again, you start with the ones place. Is the top, right, is the top greater than or equal to the bottom? So here's the difference is when we're subtracting, you cannot take away, we're in right now because they're young, we don't do negatives. So if we did, let me get a nice one.
It sounds like that is the top digit greater than or equal to. The question is she talking? Oh, she's talking about the digit in the ones place.
Yep.
I see.
Yep. So I don't know if you can see my my paper.
Yes,
So we're
yeah. So I think she's starting I mean, whereas you're looking at the whole entire number 12, subtract 9.
not
So,
necessarily. We still
okay,
just look at this part here. Can
okay,
we take away from the 2? No.
no. And
So
that's the
that's
same
what,
as hers.
yeah. And yeah. And so, but then she's like, you need a trade. If it's a no, then you need a trade. You need to take this one and you need to put it here.
Yes, so that's why I want, yeah, how do you differentiate between that versus how you do it?
How do I differentiate? It's
How
kind,
it's kind of similar. Go ahead. So let's do the way how she explains with that algorithm, and then you do yours how you explain using the abacus.
the interesting thing about her algorithm is that it doesn't, it doesn't, it doesn't really have a good example here. It would be better if the example was like 48 take, maybe do this one, 48 take away 6. Maybe that's a better one. I mean,
34
sorry,
take away 6.
sorry, 30, yeah, 34 take away 9. Let's do that. 34 take away 9. Maybe that's a better question,
Okay.
right? So she talks about trading, so you have to let's do it. Let's do 30. 1, 2, 3, 4. 1, 2, 3, 4. Oh, 3. We need 3. So we want to take away 9.
Can you
We
pin
have to
down the
take away,
ones? The
yeah,
ones right there. Yeah.
we have
There
to
we
take
go.
away the, right. We have to take away the 1. We have to take away the 9. But to take away the 9 from this group, we have to break this up,
Yes, yes, yes.
right? To break this up, what happens? I'm left with 2, right? I'm left with 2. And then this becomes 10. 2, 4, 6, 8, 10. Now I could take it away. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm left with 5.
Ah.
Does that make sense?
So
So
you, but
that's
you,
how,
so you
yeah.
have to count. You have to count 9 out, or you have it memorized that 14 minus 9 is the same as saying 9 plus 5 is equal to
Yes.
14. And so
Yes.
that's why you're having to memorize
Mm-hmm.
and know,
Yeah.
okay, to know your
Yeah.
number facts.
Mm-hmm. Yeah. So now your memorization in mainstream gets bigger. But now if we did it abacus way, yeah, I like to change colors. I'm going to change colors. Let's see if this works. So that's why I'm going to go back. Yeah, no. I'm
You can put
confused.
the number, you can put a letter M for mainstream,
Like
and
that?
then abacus A, yeah. And then when you do abacus, just say this is abacus.
Okay.
The letter
So,
A. Yep. Yep, there you go.
okay. So thank you. I do appreciate it. I like labeling too, right? So we have our 34 minus 9. Well, what do? We have to minus the 10. We
10.
know, yep, add the 1. We know what? So we do 34. We're going to substitute this in. We have to minus the 10 plus the 1. So if I did it row by row, 34, I take away the 10 and I plus the 1. Oh, yeah.
So the difference is you don't have to trade in the 10 to make 10 ones to still continue to subtract.
Yes, that and also and also we compound our information because what do we know? We know if we want to add the 9, it's the same thing but the opposite. We don't need to know 14 minus 9. We don't need to memorize this. What we need to memorize is this concept, which is only 2 things. If I know how to add, I know how to subtract,
Right.
right? So
Yeah,
let's say,
that seems so much easier, especially when you know your partners to, because the 10, the minus the 10 is pretty much the leverage for,
yes, but let's take it one step. Let's take it one step down. Let's do 33 minus 9. Well, now what? Now we got to do it again. We have to take away the 10 from here, but now we need to know 13. 13 minus 9 is what? We have to remember that 4 is equal to 13. But
yes.
here we go back. 34 or 33 minus 9 is what? We know this concept. We do it again.
Let me go
Goes,
here, Lois. And just talking. Drop them off.
that's really interesting. But yeah, right? So when we start incrementing, we don't want to have to memorize all of this because we just need to know this part here. That's why it's easier. That's why it's easier.
You sort of see the pattern with 34 minus 9 is 25, and then 33 minus 20 minus 9 is 24. You kind of see a pattern.
That's if it's together. That's if it's one right after the other, you will see it. But if it's jumbled up, right? If I did I don't know, 72 minus 9, right? You got to do the same thing. I got to make a 12 out of this, and then take it from here. Right?
Yes, that makes sense.
So we can take it another step. What if we did 97 minus 9? You got to know 17 plus 9 is what? That's a really good comparison. I'm going to make a post out of that. That's a really good post. Right? So if we did a comparison, this is M, right?
That's M.
And if we did the A, so A 72 minus 9, guess what? Minus the 10 plus the
Plus
1.
the 1.
Do it again. 9, take away 9, minus the 10 plus the 1. It's the same thing, right? So we just need to memorize this one thing and we know how to do it.
And that's why your numbers can be any number.
Yep, exactly.
Depending on whether you're doing +5 or -5 on there. So
Well, yeah, but we know that if we need to add the 9 or take away the 9, but see, now it's different. Let's say we added.
I have another question. So but with the 97 -9,
Yeah.
you automatically know that you're not going to be using the +5 formula in there
Oh yeah.
because it's greater than 5.
Yeah. It's greater than 4.
Sorry, it's greater than 4. Okay. So you already know just by visually looking that you're not going to be using the +5 in there
Correct.
for subtracting.
Anything, adding and subtracting.
Okay.
If I do 9, I'm never going to use the 5 because there's no partner to make a 5 with a 9. The focus is how do you make a 5? We're not going to subtract 9 from 4. We don't do that.
So the second add-in for here is anything greater than 5. Or no, greater than 4.
No, the second add-in. Oh, wait, what are you talking about? You're talking
When you
about this?
say like 97 minus, well, this is where you're okay.
No. So if we
Scratch
did,
that.
yeah, because if we did 16 minus 4, this second add-in needs to be a -5.
16 -4 or 96 -4?
I'm sorry, 96 minus 4.
Oh yeah, because you don't have enough beads to subtract the
The
4.
6. Yeah, exactly. You don't have enough bead from the 6 to subtract 4.
Subtract the 4.
That's why you do 5.
So you
See?
do minus the 5 plus the 1.
Yes, but because you can see it, you don't need to memorize the number that you're looking at.
That's correct. That's correct.
Because if I showed it to you, you're like, oh, I need to minus the 5. You knew that already because you saw it. But now
Yes.
when we do this, it's like, well, these are symbols, and the symbols you have to translate it in your brain,
Yes, you do.
right? That's why it's different. That's why if you could see it, you know what to do.
That makes sense. That makes way more sense.
So, so if we did, so even if we did the other way, so let's say we did 97 plus, no, not now. Let's do 8. Let's do 8. Let's do 8 for just to keep up. So if we do the 9, right? Well, they count up. They add everything. They add this together to make 16. And then they take this and they put it into here. So it's still the same thing. Whereas like if we did 72 plus 9, they count up to 11, and then they take this and they put it into here. That's mainstream. Right? But what do we do? In Abacus, it's 9.
Plus the 10 minus the 1.
What's the 10 minus 1? Yeah. Right. So it's yeah. And then we do it again. 72 is equal to plus the 10 minus the 1. So because we know how to add, we will know how to subtract. It's not a new set of information. We're just modifying, pivoting it a little bit. This is new information. Like 16, I would have to memorize that.
That makes sense.
But then let's take it one step further. We do it again. We could do it again with let's do it again with 8. It's the same problem, because if we did 87, let's do 87. 80 if we do 87 minus 8, 9, right? 9 take away, I don't know, 7. But in Abacus, we know that 87 minus 8 is what? Minus the 10 plus the 2.
Yeah, minus the 10 plus the 2.
Yeah. But see, now you have a whole new set that you have to memorize. 8 plus something is equal to 17. 8 plus 8 is 16. 8 plus, you know what I mean? So there's a whole new set. So you have one set of how to do the 9, and then you have a whole new set of how to make an 8, and then you have a whole new set how to do a 7. So then you have what?
So I think that's why they have fact families, where they have you
Yes.
you have the little triangle thing, and let's say you have
Yes.
17 minus 8, they will have 17 as you're in the, and then yes, and then they'll do the 8 and the 9.
Yeah.
And so that's what they have you memorize. So you can either go 17 minus 8 is
Yes.
9, or 17 minus 9 is 8, or 8 plus 9 is 17, or 9 plus 8 is 17.
Mm-hmm.
So that's what they have you, but that's all one fact family that they're having you memorize. So I think after a while, because they're so used to knowing.
Yeah. Yeah.
But yeah,
But that's a whole lot of memorizing.
it is. It is a whole lot of memorizing.
Right? Yeah. So and that was interesting. Yeah. That's gonna be another post. Because I don't want to have to memorize all of this. I don't want to have to memorize all of this to just get this. In comparison, that's a lot of, yeah. This is this is all you need to know how to add and subtract. As long as you know these two sets, that's why I think that's what makes Abacus superior, easier. But yes, and it is a different way of thinking because it's always about the second number. Oh, sorry, second number. Yeah, that's crazy. That's a lot of memorizing.
Yep, that's why they take it really slow.
Yeah, I could see that. I could see that. Yeah, because I did the number bonds. I was trying to do the number bonds for like Abacus and stuff, and so
You did that last week where you showed,
this that's all the number bonds we need to know.
yes, but you showed how it works with the abacus. Um, you did the formulas with it. I don't know how you did it, but you did it. You did the formulas with it.
I'll go back and I have to go back. I have to go find our last Zoom. I think I recorded it. I'm not sure. I think
Yeah, you
I
did. You did.
no, because Zoom has its own recording and I don't know if I recorded it. There was one time I didn't record. I was like, no, it was a good one too. Um, so it might have been last week that I forgot to hit the record on my Zoom. Yeah. Okay. So I'll see what I can find and see if I can figure that out again. But yeah, so all of the number bonds, these are all the number bonds we need to know. That's it. As opposed to everything else. And then what did I do? Oh, I was trying to do more questions.
I had a sheet of paper where I had some kind of math questions, I think, that was on a different set of
Email?
paper.
Yeah.
Yeah.
Yeah. I worked it out. Oh, was it something like this?
Oh, you're looking for it. There it is on top. Yeah,
Yeah, yeah,
you did. The 4
yeah,
plus the 6 is a six. Yes, that's
yeah,
how you did it. Yep.
yeah. Yeah, that's why I like paper and pen so I can always go back to my notes. Somebody was like, you should use an erasable. And I'm like, then I'll never know what I'm doing. Because I
Oh, you
still
won't.
think,
Yeah, you won't have the copy of all your notes.
yeah, yeah. So so that's what I was trying to do is I was trying to show you what algebra is.
Yes.
So we changed our x's to an unknown variable, but it's a abacus is a leverage that feeds into it. Like you know your number, But if you can see the pattern, then you can start taking and make it a variable. Yeah.
Yep. That
Okay.
makes that makes perfect sense.
Good. Good. But yeah, I was going through. Oh yeah, see? So I did do it. So here was the first question, and I did left to right and right to left. Just to practice. And so we had 213. And then we did 3, you just right to left. Excuse me. So right to left, we add the 5, and then we add the 4. Adding the 4, you can see it. You need to add the 5, right? Plus the 1. And then here is the 3. You know to do it again.
Mm-hmm.
Plus the 5.
Plus 5 minus the 2.
Yep. And then the other way is exactly the same. The reason why is because there's no carrying over. So it doesn't matter if you go left to right, right to left. So anything in the, if you add the 10, if you add the 5, it doesn't matter. But it's when you go 10, that gets a little bit interesting. That's when you start seeing it. When you borrow or you carry over. So if we had 2, 1, 3, and then we're going to go this way. We have 3, add the 5 minus the
5
2,
minus the 2.
add the 4,
Add the 5 minus the 1.
add the 5.
Add the 5 minus the 2.
Nope, add the 5.
Oh, add the
Add
5. Add the 5. Okay, yeah. Sorry. I was on
Yeah.
a roll with that other one. Sorry.
Yeah, I did that too. One time I had a question. It was like, I need to take away the 6. And I'm like, I can take away the 6 minus the 10 plus the 4. I was like, wait a minute. Or something like, it was something like this or something. And I was like, wait a minute. I don't need to do a formula because it's right there.
I have
Sometimes
to
we
remember I'm
forget.
adding.
Yeah.
Not okay. Because yeah.
So we have 1, 9, 4. And then we do 4, 2, 1. We could do 0. We add the 2 is what? Plus the 10.
And minus the 8.
Yep. Because why? Because we're already using the 5. So we know we're going to do the plus the 10. But you have, but it's nice to see it, right?
Yeah.
And then we plus the 4. Plus the 4 is?
Plus 5 minus the 1.
Yeah. So the difference here is because of the 10. So if we did it from right to left, we do it this way. 1, 9, 4. We add the 4 plus the 5 minus the 1. Add the 2 plus the 10 minus 8. And then 0.
Can you do that one more time?
Yeah. So we have 9, 4. Oh, I'm sorry. Yeah, so we're doing it left to right, right?
Yeah.
So add the 4.
Is plus the 5 minus the 1.
Add the 2.
Add the 2 is plus the 10 minus the 8. And then
0.
4. There's nothing. Yeah.
Yeah.
Okay. Because
Yep.
the 4 is already there.
Yep.
So 614.
Yep.
Okay.
Right. And so this one was, so from left to right. So the difference here is just whether we go left to right or right to left. This was not to talk about the difference between mainstream math and abacus.
Right.
Right. So here we go from right to left. It's plus the 10.
Plus the 10 minus the 5. So plus the 10 minus the 5.
And then 7. That's add the 7.
Oh, add the 7. Okay, I was about to say plus the 3 minus. Yeah. Okay, sorry.
I did the same thing. I was like, wait a minute. And then plus the 1.
Plus the 1. Yep.
There you go. So the answer is
791.
700.
I have to admit, if it's going to be easy, I mean, I will probably pick the one that least the one with the least. It seems like I keep on gravitating to starting from the left. But I'm really glad that.
Yes. Yeah.
Yeah.
I don't know what it is, but it feels more natural going from left to right.
Mhm.
It just feels more natural. But I have been trying to go right to left. So if we did it again, we do 6, 1, 6, and we go from left, we add the 1,
Mhm.
add the 7,
Add the 7.
add the 7, and then,
Um, Less the 10 minus the 5.
yep, 7. Oh, I wrote that wrong.
So what's interesting is that when you're doing the 5, you have to go back into the tens place and you have to subtract that to add, or you have to add it and then minus in the one in the minus the 5 in the ones place.
Yeah, yeah. Or, yeah, you still got to go back to go forward.
That's exactly right. You have to go backwards to go forward because
Yeah.
to finish off in the ones place.
Mm-hmm. Yep.
So that
Or,
maybe that's
or,
what that carryover is, right?
yeah, that's what the carryover is. And that's why it's still easier just because we know we're only carrying over the one bead, the one column. And then
So
having
when you're
said,
starting, so when you're starting from the left, and especially with the number being I can't see the whole thing, but anyway,
oh, oh, oh,
that's why yeah, with the 5, you're able to see that you have to add the 10
yes.
and then you subtract. Um, Kind of like how you have to in mainstream you add and you carry over the 1 and you're actually seeing that you're seeing it. So I can see where you start from the right to left. But I guess it just depends on what your number problem is.
Yes, yes, and that's what it is. But you won't know until you do it both ways, and then you see it. So then the other thing is in Abacus you could do 5 is equal to minus the 5 plus the 10, so you end off in the middle. You could do that, right? So if we had
Oh.
6, 1, 6, we have the 1, we add the 10, 10 plus the anyways 9, right?
Mm-hmm.
No, 8. It was 8. So we
Yep.
can do is minus the, so we're here. We want to add the 5. You want to minus the 5 and then plus the 10. So you're in the middle. You could
I
do that.
know I know that in I forgot Miss Abacus. I know when she always has minus the 5 plus the 10 whenever she's doing the subtracting. Yeah, on
Okay.
hers. Whereas she's using the second inverse
Mm-hmm.
or whatever.
This one. Yeah.
Yeah, she always uses that first. And I wonder if you can always visually see that you're going to be subtracting that 5.
Not necessarily because sometimes that's where you the two-step.
Ah, there we go. Yes, yes, yes.
So I don't know how she does her mixed formula, but the problem, the one that I do see is it's good to be flexible because sometimes this number it needs to be and sometimes this number needs to be. It just depends on where you are in the process. So
uh,
like so like our like here, right? Our 10 can be adding, but then was it we can either do plus the 10 plus the 1. Sorry. We can either do plus the 1 is equal to plus the 10
plus the 10 minus the
minus,
9
or it can be what? Plus the
plus the
5.
5 minus 4.
Yeah.
Uh, yep,
Then this one, yeah, obviously it can be either minus the 3 is equal to minus the
minus
10,
10 plus the 7
or it can be,
or minus the 5 plus the 2.
yeah.
So writing it out just helps you show your work. But basically, when you're doing these problems, you have it memorized, so you don't even have to write it out. You just do it.
I don't write it out, but I chant it out.
Oh, yes, yes. You chant it out.
I chant
Okay.
it out. And I think I'm going to keep it as chanting it out. Yeah, I'm
Uh,
going to keep that. Yeah, but just as I explained to you how we made the 10 and so forth with the 8, I think that's a good supplement. That's a good addition when we take the 8 and we move the 5 over here. I think that's a good supplement. But I think chanting this out is still very good.
Okay,
Yeah.
makes sense.
And so, but yeah, again, it I believe to be flexible. So we could do minus the 9 plus the 10 or minus the 4 plus the 5. Because it depends on where you are in the process of adding and subtracting on the abacus.
Okay.
I think, yeah, I think there was too many rigidity. There's too much rigidity if you can't be flexible on it being this interchange, because they do it in mainstream math, right? Mainstream math, that's why they got the number bonds. Why can't we do that
Uh,
in why can't we do that in why can't we take this concept of,
oh yeah, because they go 10 minus 4 is 6, 10 minus 6 is 4,
yeah,
and 10, and 4 plus 6 is 10, and 6 plus, yeah, okay, so yeah, that's
yeah,
interchangeable. Yeah,
yeah.
you're right.
So if this is interchangeable, why can't we do that for that? And that was the reason.
Mhm.
That's why, like, it's great that she probably does it because it's the beginning parts of the questions, right? It's the
Mhm.
beginning part of your journey. But if you go further into it, I believe you should be very flexible. Do you need to add the flexibility now? It's up to you.
I think once you've started getting familiar with it and you start to recognize, um, I think you start to become a little bit more flexible. I think one of the things that you've started to do, or what you've done, is you show what it means to start on the left and show on the right. And then I think as the person that's doing the problem, they kind of get a feel of which one they like better or which one's easier.
Yes, yes. And the reason why I do it is because I wanted to relate to mainstream math.
Yes, and it
And
does.
we as growing up, we've always started with the right. So completely new to abacus, I don't want to disrupt too much of understanding this. That's why I started with the right. And then I'll show him how to do it with the left. That was my thought process on that.
Mhm.
But yeah, as you do more abacus, you'll notice that left to right, it just seems more natural. But it does take time.
Makes sense. Do you have the other math story problems?
This one? Oh, I don't know if I did story
Well,
problem.
the one that I showed you was kind of sort of like the story problem itself. So you actually
Oh
see,
yeah.
yeah.
Um,
I would you be able to find that? We can go through a couple problems. I have to go check something just 1 second.
okay, go ahead.
Okay.
Let me see. Think I added it to this one. Um, is it here? No. I oh, here it is. So,
Oh, there we go.
yeah. I just need to make it bigger. So this one was kind of like, yeah, I started adding word problems to some of my activities. Um, so the first one is if you had 40, let me get a new piece of paper. Yeah, and then yes, I was going to add more story problems. I was going to add more concepts to it, which is really kind of interesting. I'll show you. I'm actually quite excited. So the question is 40, if you have $40, so I'm going to write $40, and then you spend $6, how much money do you have left? So back to here. So a lot of it is just trying to figure out what they're trying to say in the question. So if I have $40 and I spend $6, I know I'm going to be minusing. So the question would be 40 minus 6.
Mhm.
And then what do? We do take away the 6 here.
Minus the 6 is minus the 10
Plus the
plus the 4.
4. Yeah. So we take away the 10 plus the 4. So the difference is what? We don't, in Abacus, we don't need to cross this out, right? We do it already.
Yeah, it's shown on the abacus.
Yeah. Yeah, it's shown on the Abacus. So we don't need to, so we just do in 34. Okay, so the next one is 40, and you earn. Earn means what? You earn
Adding.
$5 is you
You
add,
add.
right? So this is an adding. This
Well,
is
this one's
subtracting.
easy.
Yeah. See, now you know, right? But because before, if we had the 4, we would have to be like, okay, 5, add the 5, 41, 42, 43, 44, 45. But here we just add the 5 because the abacus tracks it for you. So that's why when I looked at it, I was like, huh, that's interesting that the word problems. So Eden does 35 jumping jacks, right? And then we do 20, and then she does 20 sit-ups. The question is how many exercises does she do? How many exercises? So what does that sound like? That sounds like it's an adding. So all we have to do is 35 plus 20 is what? So we have 35, and then we add the 2. We add the 2, 20. We know.
Now the 2 plus the 2 is plus the 5 minus the 3.
Yeah, see, you're sounding more automatic now. Like it's more, it rolls off your tongue more. So my final answer is 55.
I probably gave pretty easy problems. There's
Yeah.
a lot harder than this.
Give me those questions and we will go through it. So it's the same thing, jumping jacks, right? Jumping jacks, and then 20 sit-ups. Then the question is what? How many more jumping jacks does she do than sit-ups? So if it's 35 minus 20.
Oh, wow.
That's
Yeah, that's on the abacus, it's
right. Take away 20. Can I do it?
but it's still easy mainstream there because the 0 is there.
Yeah. Yes. But you have to translate this in your head. Whereas on the abacus, you don't have to translate it. It's already displayed.
Yes.
Caden plants 13 inches. No, Caden's plant is 13 inches. So there's 13 inches. Olivia's plant is 17 inches. How much taller is, so we have to know what? How much taller is Olivia's plant? This is Olivia's plant, and this is Caden's plant. So we need to know that 17 will be higher than 13.
There
17,
you go.
17, take away, so we need to minus, right? Minus the 1, minus the 3. Minus 3 is what?
Minus the 5 plus the 2.
Minus the 5 plus the 2. Minus the 5 plus the 2.
So 4 inches taller.
Jason has a ribbon that is 34 centimeters. James's ribbon. Yeah, James. Okay, no, that's fine. He uses 12 centimeters.
Oh, uses means you're subtracting.
Yes. And then the question solidifies it. How many centimeters are left? So 34 and then 12. So this is easy because it's what? 34, take away 1, take away 2.
2.
Yep.
22.
So
22 inches. Centimeters. Okay.
Centimeters. Yeah. Yeah,
that's a simple problem. That's a simple problem that where you're not using any formulas there.
Exactly. And the more you see the numbers, you'll notice how they how mainstream overcomplicates all this stuff. It's really interesting. Okay, so the next one was
so I'd be curious to do a problem where you have to do the formula for subtraction or whatever. I don't know what the next one I sent you.
Oh,
So
it is 34. So 34 coins, 34 golden coins are in a sock, are in one sock, and 7 coins in another. How many altogether?
altogether is
All together, right? So it's 34 plus 7. 34 plus 7. What's plus 7? Plus the 10.
plus the 10 minus the 3.
Yeah, plus the 10 minus the 3. My answer is 41.
41.
Right? So then the other one was, sadly, 34 coins are for Boney Bill. How many coins are left for me? I don't know what that means.
I think it's from the. Did I only give?
Hold on. Let me. Yeah, I'm not. I guess. Sadly, 34 coins. So you're taking away.
Yeah, it's from the previous question.
So, okay. So if we go back, 34 is Boney Bills. Boney Bill. So we're going to 41, take away 30, right? Take away 3, take away 4. What's plus 4? What is minus 4? Minus 4 is
Minus
what?
4 is plus the 5. No, minus the 10.
Yes, minus the 10 plus
Plus the 6.
yeah, minus the 10 plus the 6. See, they were trying to get you to add the 7, take away the 7, but it's not, because this is different. Do you see that? So they're trying to do 4 plus 7 is equal to 41. But then if you minus the 7 is equal to 34, kind of a thing. That's what they wanted to do. So they're focusing, so they're focusing on the result. We don't. We focus on the second number. That's the difference.
Oh, okay. But in answering the problem and answering what they're looking for, okay.
Yeah, because they're trying to get you to, they're trying to show you that it's interchangeable, but it's not. In Abacus, it's not interchangeable. So let me rewrite it, because I did have one activity, I'll show you in my other one, where we have 7, right? And then it's equal to 41. They want to take this 41 minus 34 is equal to 7. They wanted to show you this number, I don't know, this number bond of 7 and 34. Right. So I incorporated that concept, but not the way they have it. So in here, the way I have it is I do it with the minus the
checking your
4.
subtraction. Which book is that?
This one's the plus 10 one.
Oh, the minus 10. Oh, yeah.
So this is what they're doing. They're showing you how to check. So I was incorporating how to do it in Abacus. So I said 13 minus 4 is equal to what? It's equal to 9.
It's
right?
9.
And then how do I add it to get to my number? So then you see, if I add the 9, am I going to plus 4 is equal to, and then what I'm doing is I'm trying to show you that
Abacus wise.
Yeah, the 4 is what we want to what we want to focus on.
Adding the 4 and the minus 4. But adding, okay, yes. Right. So then you go 13.
Yep.
1, 3, 13 minus 4.
13 minus 4.
And minus the 10.
Yep.
Plus the 6.
Yes. Oh, you know what I should do is right here, I should put in a thing saying write the formula.
Right.
I should write.
Did I do that right?
Yeah, you did. Say it again.
Okay, so 13. Do this. So 13 minus the 4. You can't minus the 4 and the 3, so you go minus the 10 plus the 6. Yeah, that's right.
Minus the 10 plus
yeah, because that's 9. Yeah.
Yep. So then what do we do here? So this is 9. So what do we do here?
So we go 9 plus the 4 is plus the 10 minus the 6.
It's the 6. Yep.
So should we write the formula out while we're doing it in the book?
I think so. I'm going to update it so I have a space for writing the formula.
Oh, yes. Otherwise, they'll just treat it like they'll just put in 9 and then they'll
Yeah.
just put in
Yeah.
13.
Yeah.
Okay.
I think that's what I'm going to do. I've been updating my books. It's
Okay.
just such a, yes. Oh, yeah. So we're back to here.
Yeah.
Okay. So the next one was 49 plus X is equal to 53. That's the
Yes.
question.
Mhm.
So we know that would be a what? Oh, you know what you need to do is isolate the variable.
Yep.
9 plus X is equal to 53, right? So we need to isolate the variable. To isolate the variable, what do? We have to take this and we have to minus.
Oh, so yeah, then we
Minus,
put 53.
yeah. So to make this 0, you have to take it away. Do you see that?
Yeah, that balances out because your cancels out.
Yeah, cancels out. So yeah, this cancels out. This becomes 0. So now we know 53 minus 49. So we have 53, take away 4.
Is minus the 5 plus the 4.
Plus the 1. And then minus the 9.
Oh, wait. Okay, I was starting from the
9?
the left. I guess I was starting
Yes.
from the left.
Yeah, that's what it is.
So 5 minus 4 is minus the 5
plus the 1.
the 1. Oops. Yep.
Yeah. And then minus the 9. Cannot take away 9 here. What do I do?
Minus the minus 9 is minus the 10 plus the 1.
Yep. Minus the 10 plus the 1. So my final answer is 4.
4.
So X is equal to 4. So then you rewrite it. 9 plus 4 is equal to 53.
So my question to you is because we started out with doing minus the 4, sorry, minus 4 is minus the 5 plus the 1. So you have the 1 there. And then you have 3. Because that 1 pretty much is going over to the 3 without realizing, okay, because then you're going minus the 10
Yes.
for the 1s and then plus the 1. Okay, wow, there you go. Okay. Yeah.
Yeah. Yeah, it's interesting when you start making revelations like, why don't we take away the 1 right away? You wait till you're done with the number.
But if you're in mainstream, you would take the 1 away right now.
Yes, exactly.
You would go 5, you would take 4 away and you get 1. Right?
Yes.
So when
yeah,
actually no, you start on the right. So how do we do that mainstream wise?
So mainstream 53.
Because you take the 5, you cross out the 5 and change it to a 4. And
Yep.
that's why it's 0.
Yep.
But on the abacus, they show you the process of how it went.
Yes. Step by step.
Can you explain that? Can you show that how it like verbalize it while we're doing that with the abacus?
Yes. Thank you. I appreciate that. I do. I appreciate that because I'm trying to explain it. But you know what? Funny. It's because I was going through it in my head before. So you're going through the same process I went through when I was trying to figure out like how is it different from mainstream to so when we do minus, right? If we go, here's a question. Are we going left to right or right to left? That's the other question.
I was just going to go from left to right.
Okay, so if we go left to right, then what we're going to do is we're going to minus the 1 first. So what happens is we have 1, 3, minus 9. Because we minus the 4, 5, 3. So what do? We minus the 4 is equal to minus the 5 plus the 1. So we're
Yeah.
left with this. This is our running total. We still have
I've
to
done
minus
that.
the
I've
4.
done that step before. I just kind of I just bring down the 3 and then I subtract 9 again from that. I have done that.
Yeah.
That's it's just showing 2 steps there. Yeah.
Yeah, it's
Okay.
showing 2 steps, but it's showing you step by step, actually.
Yes.
So
Yes.
now we are left with 13 because we've already taken away the 4. We just need to cross out the 4 because we've already done that, right? So we're
Yes.
still left with the 9. When we take away the 9, we know we're going to minus the 9
Just
is equal to
minus the 10
plus the
plus the
1.
1. And there's your subtracting the 1.
Yep.
Aha. Yep.
Yep. So when we replace this, let's say we replace it, let's substitute it. 13 minus the 10 plus the 1.
Oh, and then you kind of doing a 3-column thing.
Yeah.
Oh, I never thought of that.
Yeah, because what are we doing here? We're substituting, right? This becomes substituted into here. So this is what we're doing. Yeah, this was crazy when I did that. I was like, oh my God. So yeah.
Oh. Huh. Because you're used to doing that anyway.
Yeah. But to write it out like this, I was like, oh my God, this makes so much sense.
So 13 minus the 10 plus the 1.
Mm-hmm.
Oh wow. Okay. My brain's kind of going, okay, yeah.
Yeah. Does that make sense?
It does make sense.
Yeah. Because we're used to seeing it horizontal. It's different than vertical.
Oh, so you took the formula and just
Made it
the
horizontal.
last
Yep.
2 parts right there. Because
Yep.
that is the minus 9, is
Yep.
minus the 10 plus the 1. And you did it like that.
Yep.
Is that something you just started now?
It's kind of there, but I didn't want to confuse anybody.
Yeah.
I didn't want to, I didn't want to confuse them. I might add this into the adult version, but I don't think I'm going to do it for the kids version.
That would be good for the adult. Yeah.
Yeah.
I would have to recognize, I would, yeah, sometimes when you get used to writing something a certain way, I mean, but this 13 minus the 10 plus the 1 is your way of visualizing
Is my way
a
of writing.
formula.
Yeah, it's my way of writing it out on a piece of paper.
Okay.
That's the only reason why I did it.
Mm.
Right. To explain it what I'm trying to do. Because what I would do is I would just do 13. I go minus the 10 plus the 1. But to visualize, like, because we're very paper oriented, I want to show you the different way of doing it.
Okay. That makes sense.
So that was interesting.
Huh. Wow. Okay.
But yeah, and so it in this and because we're doing it this way, kind of follows the mainstream that way. Kind of.
Kind of.
Yeah. But not really. Yeah.
Because see, what I would be doing is I would be circling the 5 minus 4, and then I bring down my 1, and then I have 3, and you notice that the 9 hasn't been subtracted yet.
Yeah.
So
Oh, I
then
see.
you have your 13 minus the 10 minus 1.
Yeah. So it'd be like that. Yeah.
It would be like that. And then that arrow indicates what you still have to do. And then when you go that 3 minus 9 and you point to that 13 minus 10 plus the 1.
Mm-hmm. Yeah.
Then you can even visually see it even more.
Mm-hmm.
And so I don't know. I mean, you would be color coding for a little while until you get enough practice that this is step 1, or wait, that's step 1. This is step 2, and that's step 3, I guess.
Yeah. Yeah.
But that's really, I mean, that's for the paper wise, but really, I mean, it's really not step 1, step 2, step 3. You just,
well, see, the difference between what we're learning now and what's going to happen later. This doesn't happen until later when you become solid with the formula. So doing this wouldn't necessarily help, because if you notice, I go through like single digits. until we get solid, and then we go into double digits.
Oh, you actually show us the double digits? Oh,
No, I don't show the only double digits I show is maybe the teens, but I don't do double digits until the next book, the
what book
next
is that?
concept. After it's going to be part of the two step.
Oh, that book. Okay. Oh, and you have some problems. I think I got.
No, this one's another one. So plus the five, adding of the five has word problems. Subtracting the five, I forgot, and then adding of the 10, I think I forgot.
Oh, okay. So
So
this is your next one because I have the minus the five.
yeah, minus the five, I forgot to add in the word problem. Oh no, I did. I added word
Yeah,
problems.
yeah, okay, yeah, you did.
I think it was the minus the 10 I forgot. I think adding of the 10, I forgot to add the word problems, but I added the puzzles.
Yes.
Yeah.
Okay,
And
yes.
so then I was like, wait, I forgot word problems. So I went back to word problems in the 10, in the minus the 10. And then
Okay.
I'm trying to keep a formula of what I do and what I don't do. And
Hmm.
just forgot to keep my list.
No, okay. Yeah, I have the minus the five plus the five plus the 10. So I don't have this book yet.
Okay, yeah. This one just came out. There's this one that came out, and then I have a 4-digit maze book. So did
Oh,
you see?
yes.
So that just came out too. And then I was working on the adding of the 10. So after this would be the two step. After this is two step. So
Oh, okay.
I need to continue the Who series to continue on with the two step because this is not done yet.
Okay.
And then once I finish the two step, then I'll start going into double digits and triple digits.
Oh, for adding and subtracting?
Yeah, yeah.
Oh, wow. Okay.
But it's going to be exactly the same, and it'll be fun. But it won't be separate concepts. Every book will not be separate concepts because you should
No.
know those concepts already. You should know how to add the five, take away the five, add the 10, take away the 10. I'm just going to put it in a double digit format. So I think that's just going to be one book.
Okay.
I'm going to add in the lessons, but there will be more compacted.
Mm. Okay. That
If you
makes.
follow, yeah, if you follow the Who series. But then what I was going to do after I finished the Who series, then I was going to go into sectioning the books as by grade. This is what you do for grade 1, single digit, double digit. Grade 2 is double digit, triple digit. Grade 3 is whatever, 3 digit to 5 digit. But they would still follow the same path, adding the 10, add the 5, minus the 5, add the 10, minus the 10. But I don't know if they're going to be two books or one book when I do the double digit for the grades. I don't know. I haven't figured that out yet.
Oh, okay. Okay.
But that
You
you
could
will,
combine it like this is grades 3 to 5 or something like that, but I don't
yeah,
know.
I can combine it. But then the problem is I don't want the book to be too fat.
Big, that. Okay, yes.
So that's why it'd be because I want to try to keep the books like 100 pages because then it gets the kids to be like, I've accomplished something,
Yeah.
you know. So then after understanding how to do understanding how to do the plus the 10, you can go into cumulative addition. Where do I it? And I was going to actually start that. I should have started it in the adding of the 10, but I forgot about it. Whereas we start doing times table. But to do times table, you need to know your adding of the 5 and adding of the 10. So this would be, 2 plus 2, 2 plus 1, 2 times 1 is 2, right? And
Hmm.
then this one is 2 times 2. 2 times 2 is 4. 1, 2, add the 4. And then you need to add another 4, add another 2. What is 2 times 3? 2 times 3 is plus the
Plus the
5,
five minus the two. Okay. Yeah,
3.
three. Yeah.
Yep. And then we do it again. 2 times
Well,
4. 2 times 4. Can we add it? Yes, we can add the
yes.
2. Then 2 times 5 is what? Plus the
10.
10,
Yeah,
right?
plus the 10
Minus the 8.
minus the 8.
And then 2 times 6 is
12 plus two.
12,
That's easy.
right? And then 2 times 7 is
Is
14,
plus 14.
right? And then 2 times 8 is plus the 10, plus the 5
Plus the
minus the
5
3.
minus the 3.
So we get 16. And then 2 times 8, 2 times
Plus
9 is add the
plus
2.
2.
Yeah. So I should have added this in for the plus 10s, but I didn't.
Oh, okay.
Because then it would be the beginning parts of multiplication.
Okay. That makes
But
sense.
yeah, I would have to update. I'm gonna update it. I think I'm just gonna create a new book. I'm not sure. But for online class, I need to add this in because you could do the same thing with the 3, 4s, and 5s. But then when you get to 6, you need to know your 2 steps.
You do with,
Yeah, 6. Yeah. So let's do
can you
it.
give an example?
Yeah, yeah. We'll do 6 times table. So we do 6 times 1 is 6.
Equals
6,
6.
2, 3, 4, 5, 6, 7, 8, 9. Right? This is all 6.
Mhm.
So 6, 6, 6. Okay. And then, so we know, and I think this is how I was going to set it up, like this, and I'd have like I live very close to the fire station. Oh, you can't hear it. Okay, good.
I
Okay,
cannot
good.
hear
Good,
it.
good, good. So we have 6 times 1. 6 times 1 is 1, right? This
6 times
6 times
6.
6 plus 2. 6 plus 6 is what? Plus the 10 minus the 4. Plus the 10 minus the 4. Minus the 4 is minus the 5 plus the 1. Minus the 5 plus the 1. See, right off bat, that's a 2-step equation.
Oh,
That's why you need to know your 2 steps before you do additive addition. So 6, again, add the 6. I add the 6, right? We're okay with that. Now here, we want to add the 6 again. Add the 6 plus the 10 minus
minus
4.
the 4.
Can't do it. Plus the 10 minus the 4. Can't do it. Minus the 4 is minus the 5 plus the 1. Minus the 5 plus the 1. We need to add the 6. Can we do it? No. Plus the 10 minus the 4. Plus the
Plus the
10
10 minus
minus.
the 4. So it's, minus 4. Oh, yeah, you could minus it. Okay.
Yeah.
It seems
And
like it
then,
feels like it's almost every, well, no, it's not quite every other one because you are using the formula. You'll be using the formula here on out.
yeah, exactly. Exactly. And then we do it again. Plus the 6 is equal to plus the 10 minus 4. Plus the 10 minus the 4.
Minus 4 is
Minus.
minus the 5 plus the
Yep.
4.
Yep. See how you have to really know your formula. And then we add the 6. And then finally, plus the 10 minus 4. Plus the 10. See, now there's more. We have this is what? Plus the
Plus the
5,
5 minus the 4.
right? Plus the 5 minus 4. And then plus the 4. Minus the 4.
Oh,
Minus the
minus the
4s.
5 plus the 1.
Yeah.
Okay, so my question is, why is it times 3 and times 6 and times 8, you don't have a formula?
Why? Because when I look at it, if I have 12, do I have enough to add the 6?
Okay, so that's the question I keep on asking each time I do it. Do I
Yes.
have enough to add the 6?
Yes. Yes. It's
Okay,
always, do you have enough to add the 6? That's why.
I see. And
Yeah.
that's why times, okay, I was just seeing if there was a pattern.
Yeah. You know what? I haven't figured that out yet. I haven't done this long enough, but I haven't done this long enough to figure out if there's a pattern. I don't know
Okay,
yet.
I was just seeing that. Okay, I like that. Okay, so you do that with all of the ones, all of the, okay,
Mm-hmm. Mm-hmm.
okay, I like that.
So I forgot to introduce the beginning parts of adding cumulative addition, because what is what is it? It just means that multiplication is just fast addition. We just did shortcuts. Oh, shortcuts. So this is a shortcut to addition. If we do multiplication, at understanding your multiplication fact family is a shortcut to doing multiply. Oh, yeah. Shortcuts.
Okay, say that one more time.
Okay.
Say.
So we say in mainstream, we say we need to know our multiplication fact because it's a shortcut to addition, right? We know that if we know 6 times 9 is equal to 54, that's a shortcut. This is a shortcut of 6 plus 6 plus 6 plus 6 plus 6 plus 6, plus 6.
Yes.
That's a shortcut.
Yes.
Abacus introduces shortcuts early because we know instead of doing 12, we do 12 plus 6. Instead of saying 6, 7, 12, 13, 14, 15, 16, 17, 18, instead of counting it, we know the shortcut is minus plus the 10 minus the 4. This is our shortcut. So we introduce shortcuts early on.
Oh, I would have never thought that.
That's why the concept is relatable and it's transferable. Oh, that's brilliant.
Okay. Wow. Okay. So can you write abacus shortcut up there?
Forgot your paper.
So do we actually recognize that when we're doing it?
No,
I haven't been on it yet.
no, we don't. We don't recognize it because it's never been thought that way.
Oh, but this is only applies to multiplication, right?
Yeah, we talk about it in multiplication that this is a shortcut. Yes, we talk about that, but nobody has ever mentioned that abacus is a shortcut to, because I do know that when we do number lines, what a pain in the rear on that one. So we do 12, right? We do 1, 2, 3, 4, 5, 6. So what we're doing is we're always doing 1 to 1. That's 18. So this is 6, right? So we're doing a 1 to 1, and it's always counting up. We're always counting up. We never use a shortcut to make a 10 or make a 5.
No, because they want you to count individually.
Yes.
Each number.
Every number. Yeah.
Okay.
Yeah.
Wow.
That's yeah. So this is mainstream, right? This is mainstream, and then this is abacus.
Yeah, I guess you would say that the formulas are a shortcut. Okay. Never thought of that. I like it.
Yeah. It's interesting, like, and that's why I'm here. That's trying to figure out how to get whatever is mainstream to abacus. And I tell you again, I do appreciate your conversation with me because it does spark so much connections for me, like how to bring it to light.
Okay.
Thank you.
You're
I
so
appreciate
welcome. Yeah. Yeah. I just yeah, I always go back and I always go and listen to it.
Yeah.
Because then it helps me just to see. So, but yeah, I totally understand, your StreamYard or whatever. And I guess I personally don't mind my voice being on the internet. It doesn't bother me.
Okay. Okay.
Because you can't see my face, so that's really funny.
Okay. Okay. I appreciate it. And you're right. You're absolutely right. It's always nice to hear what the other person is saying because the connection, what you're trying to go through and what we're trying to talk about, it doesn't help when it's only one-sided.
Yeah. Yeah.
So I found that out like later on. I'm like, oh my gosh. Because when I do my TikToks, there's nobody on the other side. So that's the limitation of StreamYard is that it doesn't capture the it doesn't capture the voice on the other side, the sound on the other side.
Okay, so like for this live, it doesn't catch that then?
I have to because I recorded Zoom, I can take the Zoom and I can upload it to YouTube. That's what I have to do. But see, other people, what happens is they're sharing not Zoom, they're sharing a web page, and you could share the sound on the web page. That's the difference. So I'm trying to share my sound through another application, and
Oh, wow.
they don't do
Okay.
that. Yeah.
Okay. So then when I go back to YouTube, that's why I only hear just your voice, correct?
Correct. Correct.
Okay.
Because it captures from my my microphone.
I see. Okay.
Yeah. Yeah, it's a little sad. I'd have to figure out like another application that will do sound on all platforms.
Oh, because you're trying to get to more than just YouTube. You're trying to get everybody else. Because that very first one we did, you could hear my voice. The very, very first one that you did.
I
The very first Zoom you did, you
I
heard my
did?
voice.
No, did it? Oh, then if
Uh-huh.
that's the case, then Zoom is then StreamYard is a little finicky. Because sometimes the volumes will cut out. And that's what makes me mad. Like I tried it when I try to do TikTok, my TikTok lives,
Mhm.
sometimes I can hear my voice, sometimes I can't. And I
Oh,
just
that's
have to
very
end it.
frustrating.
Yeah.
Okay, so it
And I have
has
to end it.
nothing to do with you. It has to do with the other people there that you're using. So,
Yeah, yeah. So if you don't see me on YouTube and you can't hear the sound, then I cut out, then I just turn it off because there's no point. So what I want to do, but the other reason why I want to try to do is bring my TikTok lives to YouTube because I have sound effects.
oh yes, I heard a couple of the sound effects. Hmm.
Yeah.
Yep.
So but yeah.
Your what is it? Oh, Bob the Builder. I've heard that one.
Oh yeah. Yeah. Yeah, but see the difference between like what we're doing here is because we're going more into it. I don't have to talk about the beginning parts. So I mean, that's why it's nice to have like TikTok just so I can practice like the beginning parts, but I like this because we can start deeper, dig deeper into understanding the difference between mainstream math and abacus.
Okay, and then you have some problems where you can actually work out and just demonstrate what those look like.
Yeah.
Um,
Yeah, but they're
okay.
not in depth, right?
No,
They're
this is
just
a
kind
little
of
bit more in depth. Those
this
are a
no.
little,
Yeah. Yeah, because don't forget the people that are coming on TikTok, they're all new. So it's like the first day you met me, you didn't know what's going on. But as we continue to talk, I mean, this is what 10th or 20th time that we're together. So
mhm,
you have a stronger foundation. It's easier to talk to like the higher concepts.
mhm,
Whereas in TikTok, it'd be the same thing over again. I just be counting. I know how to count really well from 0 to 9.
mhm. Yep.
And I've always been worried about like what am I going to say, but I noticed that when I produce the content, it's the same thing because it's always going to hit somebody else. So I just count again, just every time. But that's why I enjoy these conversations because we can dig a little bit deeper into the theory behind mainstream math and abacus math.
Okay, yeah, and then just me asking you, okay, so how do they carry over the wand and just showing the differences? Yeah, yeah.
Yeah. Yeah, because this part here I would do on my own, right? And I
Mm-hmm.
would really think about it and be like, okay, why are they doing it this way? So it's nice to have like somebody to talk to about it.
Feedback or
Yes,
your thought.
feedback.
Yeah, okay.
Yeah, like bounce ideas off.
Yeah.
So, oh, that was the other thing I wanted to show you. There was another thing. So, depending on how far I go with the whole abacus thing, I don't know. I'm
Miss
still
H.
figuring this out. Is like you can actually use abacus for how to find the interest rate, but you need to know the concepts. And that was another thing. I was going to introduce exponents. I'll show you about that in a little bit. So the question is I have 6,700 invested in the simple interest amount. This is not for kids. This is for a little bit older, right? But the idea is after 3 years, the total value is 7,162.30 cents. Determine the interest rate. So now what we need to do is we need to understand the concept. We need to set up our question. We need to find the interest rate. To find the interest rate is 7,162.30, which is fine. And then we just need to subtract 6,700. So I'm going to subtract 6,000 and then subtract 7 minus the 10 plus the 3. So my final answer is 462.3. So we know how much we gained in interest. Now what we need to do is we need to figure out what is the interest rate. To find the interest rate, we know our interest is 462.30 is equal to P is the principal. Principal is 6,700. The R is what we're trying to find, and the T is time. The time is 3 years. So what we do is we're going to clear this out. We're going to distribute the property. This is how we do multiplication. We did multiplication, right? 6 times 1, 2, 3, 4, 5. 6 times 3 is 18. 1 and 8. And then 3 times 7 is 21. 21. Add the 2, add the 1. Add the 2 plus the 10 minus the 9. Add the 1. So my final answer is 20,100. So we have R, but we need to isolate the R. To isolate the R, we need to divide 20,100 divided by 462.30. So when we work it out, we can do the division, and it comes out to be 0.03223. But it's the concept.
How did you do that division at the bottom there with so many?
Oh, so I would have to change it to this one. Okay, so we can do a little bit of division. So division is, so when we do division, but take it one step at a time, right? You'll understand how to multiply, you'll understand how to divide. So the first thing we do is we need to find our starting point. We have 3 digits, 1, 2, 3 in our dividend, and we have 5 digits in our divisor, 1, 2, 3, 4, 5. I have to set it up this way. 3 take away 5 is minus 2. So when I put it on my abacus, we have to count 1, 0, minus 1, minus 2. So our number line this is our number line. So this is where I would be. That means I need to, shoot, I should have did over here. Sorry. 1, 0, minus 1, minus 2. Why do I need to do this? Because I want to put my divisor on the abacus. 4, 6, 2, 3. 4, 6, 2, 3. Now, the first thing we're going to do is we're going to understand, now I have to set it up. 2 times what is equal to 4? Because I'm over here and the 4 is bigger, I need to skip this column. So 2 times 2 is equal to 4. So I take away the 4. 2 times 0 is 0. 0 is a single digit. Take away 4. 0 is a single digit. I take away 0 here. And then 2 times 1 is 2. 2 is a single digit. I take away 2. Okay, now I'm done. So I got to count it again. Where are we? Here we go. What times 2 is equal to 6 or less? 2 times 3. But because I can divide it out, I have to skip this. So it's 2 times 3 is equal to 6. I take away the 6. 3 times 0 is equal to 0. 0 is a single digit. I go back 1 column. 3 times 1 is equal to 3. 3 is a single digit. I take away 3. So then my final answer is 1.021, 3. 0.023. And that's my answer. Because I said that this was my ones. When we get there, it'll be easy. But right now, you're jumping into something that's a little bit higher.
Yes. So now I noticed when you were doing the subtraction where you go -1, then 0.
Yes.
It's kind of like the number line.
Yes.
Is that to keep track? Can you
Yes.
put a little piece of paper that helps you to know? Or do I just need a trust? Because that was overwhelming.
Oh, see, that's why if we were to really do it, I would give you like something like this. This is what we would do.
Oh,
This is the beginning parts, right?
yeah.
So we would do 2 digits, take away 1 digit is 1. So you start here. What am I going to do? I got to put my divisor here. Put 90, I put 8. And then what do? Now I compare. Now I figure out my question. What times 2 is equal to 9? Because I can do this, I have to skip one column. I have to be here.
What,
What
say that
times
again? Why do you have
what
to skip it?
because I can divide 2 into 9, I have to skip this column. That's it.
Oh,
I have to skip this column because I can divide it. Because I can
okay.
divide it, what times 2 is equal to 9 or less?
4.
So I add my 4 here. My quotient is here,
Okay.
right?
Yep.
So what do I do?
Then you
2
minus
times,
then you
yeah,
minus the quotient.
no, my minus the product.
The
2
product, there we
times
go.
2 times 4 is equal to 8. I have to take away 8. So I take away the 8, 5, 6, 7, 8. And then what do? Now I compare. Now I have to check to see my answer. I still have dividends. I still have dividends. So the question is 2 times what is equal to 1? No, I can't do it. I have to I have to make it 2-digit. 2 times what is equal to 18 or less?
9. Yeah, 9.
9. So I add my 9 to my quotient. I take away 1. I take away 8. So my final answer is 49.
Oh,
But it's all about the numbers. If it's too many numbers, there's a lot of things going on.
I see. So you're keeping a tally of what you're subtracting on one side while
Yes,
you're adding to
the
or
quotient.
the
Yes,
quotient
to the other
that
side.
goes on the top.
Yeah,
Okay,
like that.
okay,
Yeah,
okay. We're just
yeah.
so used to uh
Paper.
the tallying on the far right. We're used to subtracting that
Oh,
uh
yeah.
when you're that
Yes.
that's that that is a learning curve in itself because you're doing multiple things at once, whereas
Yes.
mainstream math, you're subtracting and then you put whatever numbers on the top. I have to admit, this is a little bit more challenging.
It's
Um,
only challenging because it's unfamiliar.
okay.
It's only because it's unfamiliar, because it's a different way of thinking. But it's actually a lot easier because when we start getting into double digit, it's
Oh,
so
that's a totally different.
it's so
Okay.
much easier doing abacus way of double digit. But I have to show you the the fundamental first before I go into the double digit. So
Well,
after doing 2 digits, we do 3 digits. After 3 digits will be 4 digit. After 4 digit, you do it enough times, then we do 2 digit. But that's the plan.
okay. Okay. I see. Because you've
Yeah.
been practicing.
Yeah,
Okay.
yeah, yeah. Because you practice, right? You'll understand the formula. You'll understand what you're trying to do here. But you'll notice what we do is we do multiplication. We find the missing factor. That's why you need to know your multiplication facts. You need to know your multiplication solid.
I see.
Because if you notice, we never say how many times does 2 divide into 15.
So what if you make a mistake? What if you don't say 2 times 7 is 15? What if you end up saying like 2 times 6 and then you're subtracting 12 from there? What
Or if you,
happens if you make a mistake there? You know what I'm saying?
yeah,
Because
so
you
if that's,
just,
so then you're going to have more than the 5, 8. So we take away, you said 6, 6. So we would take away 1, take away 3. So what do we have left? We're going to do 3. So then you're stuck because 3, you can take 2 times what is equal to 3 or less. Since you can take
2
away
times 1.
3, you're stuck. So you know you're doing something wrong here.
Okay,
So you have
that's
to,
what I want to know. Yeah.
so you add the 10 here, or you add the 1 here, and you just take away the 2 here. Ha, 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 ha. That's brilliant. Oh, that's brilliant. Okay,
Okay,
got it.
so what do we discover?
Okay,
'Cause-
so yeah, so we're going back to 15, right? Okay. Okay. So
Oh, it
another,
brings a loop. It brings you back to a loop, doesn't
it
it?
brings you back to the loop. So you said you had 6, right? So we
Yeah.
have 3.
Or
So
no, yeah.
yeah. So
If
the
it's
question is 2 times what is equal to 3? Well, I can do something. I got to go back. So I was going to be here, but I got to go back to here. I need to plus the 1 here, add the 1. So then it makes me 7. So it's actually 2 times 7 because this is 1. 6 is already on my abacus. 2
oh,
times 1.
so you're able to catch your mistake.
Yes, yes.
Okay,
Add
yeah,
the
I was just
1.
one.
Take away the
Oh
2.
wow. Okay.
Yeah. Nope. That's a good question. That's a good question.
Okay.
So then you're left with 1, and now you can't do anything. Or you're left with 1. Sorry. I got to figure this one out. But you're left with 1, right? Take away 2, you're left with 1. So then we're back to 2 times what is equal to 1. Can't do it. You got to bring down the second number.
Oh. Okay.
Oh, that's a good practice. That's a good practice. Okay. Because what happens is when you get to too much, you got to do it again. So this is, yeah, okay. Because there's another one. Okay. In abacus, when we do 2 digits, it gets a little strange because we sometimes we do too much or not enough. So you need to be flexible to either add and go back to the loop or to do the loop. That's what it is. You have to,
Oh
oh my
wow.
goodness, we've been on for like 2 hours.
Yep. Yeah, we have. Oh wow. Okay.
Yeah.
Oh, okay. My head's spinning,
Okay.
but I just
Okay.
I just wanted to, yeah, because in the mainstream, you would know that you would be your number is not as close because you'll still have a remainder left over that you have to figure out. So
Yeah.
like if you did, yeah, so um you you know, yeah, it's a lot to digest.
Yeah,
So
this is a lot. This is a lot. The division and multiple, that's why I don't do division and multiplication just yet. You need to know this. Once you get to this, then we can start slowly going into it. That's why I try to increment, a little bit at a time. So that's why we did this part, but you have to know your second, you have to know your 2 steps.
I like that. I like that. So now that's one way of just so if you're going to start with your multiplication facts, then just start with your we already know 1 times 1, but start with maybe your twos and you
Yes.
go up to 9 is the farthest you go. You don't go do 10 or 11 or 12, right?
Right. Do you know why?
You said it's redundant.
Yeah. So let's do uh 12 times 9, right?
Mhm.
So this is the beginning parts of understanding distributive property. I don't teach FOIL. FOIL is an acronym and it's not scalable. What we're doing is we're doing distributive property.
What's FOIL?
Property. FOIL. First, it's an acronym. It's so dumb. Sorry, I shouldn't knock it. Outer, inner, last. last. And it only pertains to if you have 23 times that by 24. Foil means first, this one. And then outer is this one. Inner is this one. And then last means this one.
Can you write foil right there?
Yeah, so it's F O I L.
Okay.
First, outer, inner, last.
And then your distributive would be,
It's just this. You take this number and you do this. That's all you're doing.
oh.
That's all you're doing.
So you say that the foil is confusing.
I think foil is confusing, but it's not scalable, because the problem is when you get to 3, 4, 5 times that by 3, 6, 9, what do you do? What's inner and what's outer? What's inner?
Oh, because they have the same amount of numbers.
It doesn't even matter. Even if you did 36 times that by 78, or 78, 3, 78, 8. How do you know what's inner and outer? This only pertains to, I think, only pertains to 2 digits times 2 digits. What happens if you did 1 times 7, 8, 9? Or what happens if you did 3, 4, 7 is equal times that by 24? Now what do you do? I don't know. I don't like the acronym FOIL because it doesn't scale to more questions.
I
Just
see.
like memorizing doubles, right? 4 plus 4. That is only a one. That's only very small number of stuff.
Okay.
It's not scalable.
Okay.
Okay, so going back to here, we still have to count our digits. 1, 2, 3. The reason why is because we need to know where to put our answer. 1, 2, 3. So we're over here. So 9 times 1 is 1. 9 times 9 is 9.
So 0,
Nine-
once you go to the tens.
Zero, no, 0, 9. We want to make our 9 a double digit. So it'd be
Yeah.
a 0 and a 9.
Yeah, you put the 9 in the in the
Yeah.
tens place. Yep.
Got it. Okay, good. So 2 times, and then the next one is 2 times 9. Add the 1, add the 8, add the 1. See, now you need to know, how do you add the 1 here? Plus the 1 is what?
Plus the 10 minus
Yep.
the 9.
Yep. See, you need to know your multiplication fact and your 8 and your addition. You need to know your formulas to do this.
So 108.
Mm-hmm. Oh yeah, sorry, 108. Yep.
I get mixed up with what place I got. That's the part that I get mixed up every once, because I knew I was supposed to go because 9 times 1 is a single digit. In other words, when you're saying single digit, it means there's only 9 beads.
Yeah, go back 1 column and 9 beads. You're exactly right. You're absolutely right. Because you know it's only 9 beads, you got to go back 1 column.
Right.
Because we started here, but that's technically the tens. We start with the tens.
Yep.
And then there'll be the ones. So because 9 is here, it'd be like that. 0, 9.
Would it be 0 in the hundreds and then 9 in
Yes.
the tens?
Yes.
Oh, so you have
yes.
10 and ones. So you
Because-
mean 0.
No, because I'm doing this. This is my tens. This is my ones.
But the 9 is
This-
going in the tens place though.
But that's
When
if
you
you're
go-
on the abacus.
Right.
These are two different. These are two different.
Oh, I see.
Because
Okay.
we don't need to say 10 times 9. We don't need to say 10 times 9. We're only saying 1 times 9.
Okay.
right? So we're making it manageable chunks because that's why we don't learn our 10 times table
Okay.
because it's redundant. That's why
Mhm.
it's redundant because 1 and 10, because the abacus tracks our number, we don't need to worry too much about the 10 times 9.
Multiplication is a little bit easier, but I'm not doing triple digits yet. So, and I know my facts,
Yeah,
but
yeah,
when,
yeah, yeah. But
but
because, yeah,
when you're getting to those other books, when you're teaching a child, and you're teaching multiplication facts, your one sheet of paper where it has like that dinosaur thing,
oh, yeah.
that really makes sense. It
Oh,
just
hold on.
teaches them.
Yeah. The accumulation and stuff. Did I have it here? Yeah, yeah, yeah.
Yeah,
So
that.
yeah. Yeah, I was trying to add in story to the numbers. I mean,
Right.
it's not true, right? Because you can't go backwards. You can't say two, I don't know, two dinosaurs, because it'd be, I don't know. Yeah. It's not yeah. So I try to add the story to it, and I talked about the mother, father, and then they go to. And then what I
Yeah.
wanted to do is I add the one here, you add one here, so you know you're just adding one to this side, and you're just adding 3 to this side. So I was trying to get more fluidity
Mhm.
of like how to write different ways of multiplication. But thank you. I appreciate that. I was going to make this into another book. I was going to do separate books. Twos, threes, fours, fives, six, seven, eight, nine. Those were
Ooh, that'd be
the
good. That'd be good for multiplication.
those will all be separate books because I don't like how they just combine it all and they just expect the kids to know it. So that's why I want to
Oh,
separate it. And so what I did here was I also wanted to go the reverse. So if I what is it? Like no. Yeah, so the reverse. So if I know 7 times 3 is 21, I know, and then I showed 7 times, so 7 plus 7 plus 7 is the same as the other way.
mm-hmm.
And then and then because it's multiplication, I'm going to introduce division, which is just the missing factor of multiplication. So that's part of it.
Oh, wow. So
Yeah.
you're working on this too as well?
This I haven't been on this for a little, it's been about a year since I've done this one.
But this you
But
can get that teacher by teacher, right?
what do you mean?
The teach do you I saw that part of that on teacher
Oh,
pay
teacher pay
teacher.
teacher. Yes. Yes, you can get this on teachers pay teachers. Yes. Yes.
Okay.
Yeah, if you wanted this one. But I stopped at 3. I was trying to do more, but then I started getting I started going down the path of more
Abacus.
adding and subtracting.
Oh, okay.
Yeah. Yeah. I have a lot of like ideas. I have a lot of activities. It's just taking the time to do it all.
Yeah.
But yeah, my plan for the multiplication was have its own, that would be its own series for the
Oh, wow.
multiplication. And
Yeah.
then once you get that, then I was going to have a separate series to do mazes with multiplication.
Okay.
So you've seen this. And
Yes, I
because
have.
I talk about it to the adults because they already know the multiplication fact. But yeah, but that was for specifically for the kids to make it more story like.
Yeah.
Yeah.
I like it. I like it.
Really?
Yeah, I do. So
You.
it's some parts are overwhelming, but the way you explain it, you're especially when you're going back onto the lives, you're able to pause it and ponder it.
Yeah.
And then you're
Yeah.
visually seeing it. You can okay, just take it in little chunks at a time, and then it starts to click. Kind of like we're doing the formulas right now. It's starting to click a little bit. It's becoming more
Yes.
automatic.
Yes, it is becoming more automatic because you're starting to notice. Here's another thing. I don't know if you noticed. Um, one last thing. When we did when we did the, where are we? I'll just rewrite it. So remember when we talked about uh the twos? 2, adding the 2 is plus the 10 minus 8, right? plus the 2 is equal to plus the 5 minus 3. If you notice, 3 and 5 is equal to 8.
Yep.
Yeah. That was a cool thing about it. So 3 is the same thing. Plus the 10 minus 7. 3 plus the 5 minus 2.
Oh, okay.
You see that? It's funny. It's amazing how simple it is. Minus the 9 is equal to plus the 5 minus the 4.
So is that a pattern that we're able to see then?
Yeah, that's the
Or just how
pattern
the
you can see.
form, okay.
That's just how the formula works. That's just how the numbers work. I'm like, oh my God, that's crazy. But that's what you show, that they're all related. That's why, yeah.
Oh, okay, okay.
Let me just finish it out. Minus 6. 4 is equal to minus plus the 5 minus 1,
Um,
right? So if we just get the numbers, that's how they're related.
So in a problem, you can tell that whether you're using, because like, okay, I think I
Well, in the
understand.
problem, I think it's just a novelty to see. But in the
No,
problem,
okay,
you'll know that it's an adding of the 5 or taking with or adding of the 10. It whether or not you can add the 5, I think that's the thing. But I think for me, it was just a novelty on how they just kind of relate to each other.
relate to each other. Yeah,
Yeah.
I like it. I like it.
Yeah, just more ways of thinking numbers. And it's just interesting on how like using the abacus can show you the patterns.
Mm-hmm.
Because you can never see the patterns when you're writing it out,
No.
right? Because if we add the 10 or add the 10, take away the 6. Take away the 6 is what? Right? This is take away the 6. But
Mm-hmm.
notice it's also the 5 and a 1. That's what 6 is,
Oh, yes, 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 yes. I
right?
see what you're saying. Now, okay, now that you did that,
Yeah.
it is.
Yeah, see? And that's the thing. Like you can write it, but it doesn't make sense. But when we want to add the 3, guess what? Adding the 3 is 7, right? Add the
Yeah.
5 and the 7, right? This
And the
is,
5 and the 2,
yeah,
take with you. Yeah.
yeah. That's the number pattern. Crazy, right?
Oh,
Yeah,
I like
it's
that.
crazy.
Okay, I see what you're talking about.
Yeah,
Yeah, okay.
yeah.
I like it.
Yeah, and it just solidifies, and again it solidifies the concepts of your or your number bonds, your pairs.
Yes, it does.
Oh, it's so amazing. It's such an elegant, simple tool, but it's amazing like what happens when you could see it.
So this is what you visually see on the abacus.
Um,
A visual presentation.
yes. Yeah. Ideally is the visual presentation of the abacus.
Hmm.
But again, because I've been playing around with and I notice, and then when I have my students, they started noticing things too. And I'm like, oh, that's brilliant. So, yeah.
Cool. I love it.
Yeah.
Thank you.
Yeah. I'm sorry for the headache.
No, that's okay. That's okay.
But yeah, I'll see what I could do about the YouTube and make sure that we have both of them.
Okay.
I don't even know. Oh yeah. Okay, cool. I don't know if it's streaming or not, but I'll see.
Okay.
Cool.
That'd be awesome.
Yeah. No,
So,
thank you. It was so strange. Like people would watch it and I'm like, huh, okay. That's a lot of information all at once though, I feel like. And a lot of information, but I just need to my idea was just to get it out there because the more I talk about it, the more it's out there, the more reach I want to get.
Mhm.
So
So
I
do you
know.
get more viewing on your TikToks than on YouTube then?
Yes, but yes, I do. I do. And even if I
Okay.
go live on all the other platforms, only like maybe two people are here. Hey, Diggy is still here. I got my graphite. Oh, sorry. Um, yeah, there's a person on YouTube and I just saw the message. Anyways, um, what was I saying? Oh, yeah. So the way the algorithm on TikTok is very nice because they will just keep feeding you people, whereas the algorithms for TikTok and all the other platform, I'm sorry, YouTube and all the other platforms, they don't help you go live, whereas TikTok helps me go live, and so I get an audience. See, like
Okay,
for you, yeah, what?
that's why I hear you're talking to many different people. When I
Yes,
when I go back and because your YouTube is streaming your TikTok lives is what you're saying.
correct, correct. And
Okay, and
and
that's why you
and
get lots of people.
yes, and I have to repeat myself over and over again because there's people that come into the room and the people that leave the room.
Okay.
Whereas it's different for this is the office hour. Like you're going to be here. Like I'm
Mhm.
going to be here at 9 o'clock, and we start talking, but we talk from where we left off. So there's more of a continuation. That's why I enjoy having this as a separate time. Because I was thinking about doing TikTok at the same time here, but then it would be overwhelmingly always new same thing over and over again. We would never get to
Okay.
this part here.
Okay.
Does that make sense?
Yes.
So, yeah, I mean, you could watch the TikToks, but very rare do I start talking about epiphanies like this.
Okay. And this is where you get that chance.
Yeah, this is where I get the chance because you have a foundation. I don't have to teach you how to count. You know what I mean?
No. No.
So, you already have a foundation. You're already growing, so it's easier for me to leverage off that.
Okay. Makes sense. Makes
Yeah.
sense.
So, I mean, yeah, you could watch the TikToks, but I don't know. You could try to find like multiplication because I do the beginning parts of multiplication, but I don't do advanced multiplication.
Would I be able to bring more story problems? Because I really liked how you did that one story problem with the big one anyway, what you're talking about trying to figure out the PRT or whatever.
Oh
If I
yeah, the
brought
interest rates.
on, yeah, more story problems like that, would
Yeah,
that work? I mean, these are very simple because this is kind of where he's at,
yes,
but
and
um,
you already know how to do it.
I already know how to do this,
Yeah,
but it just helps me to be able to
yeah,
explain it better to him, help him see it visually.
yeah, yeah, yeah.
Okay,
Bring it all. Whatever you see, whatever you find, you want to talk about. Let's do it. That's
okay,
that was the reason why I wanted office hours. So yeah, that's the reason why I wanted office hours. So then you can bring in any question you want to talk about, like abacus, arithmetic related. Oh, that was the other thing. One more thing. Exponents. I was really excited about this because my kid is seventh grade, like he's going into seventh grade. So I'm helping him and I'm like thinking, how do I abacify it? So what's an exponent? An exponent is just like 3 to the second power or 3 to the third power. That's all it is,
mm-hmm.
right? So what is it? 3 times 3. Oh, I can do that. Not a problem.
Yep,
And then
9,
3 times 3 times 3. So I just need to
21.
explain the concept.
No, that isn't 21.
Oh,
That
this one
is
is
20.
9. This is
That's
27.
27. Sorry,
Yeah.
yeah.
So what I would do is, what I was going to do is I was going to introduce this in Abacus where we have 9 and then times that by 3. And then the only thing that's different is what? I'm just explaining the concept, but they need to know their multiplication fact. And then I
Yes.
can add in any exponent. So I could say like 24 to the fifth power. So it'd be 24 times 24 times 20. So then it would just be bigger. Yeah. So I was thinking about adding that as the towards the end of the multiplication exponent.
Oh, oh,
No, it's easy because you just
it,
need to break it up. That's it,
oh, okay. Okay. Okay, I see.
right? You just need to break it up. When you
I
break it
see.
up, then it's easier to do. And then you could do this on the abacus because you could just do 24 times 24, 24 times 24, do it again, right? Take this answer here, take this answer here, and then times it
And
again.
then you bracket it. Okay, there.
Yeah.
Oh, okay. Okay. Once you wrote that, when I saw it, I was like, oh my gosh.
Yeah.
Okay.
And then that's what I would
So
do.
what, you know how, I don't know if it's associative or so I would put, you would put brackets around 24 times 24 and then 24 times 24.
You
Yeah.
could, you
Okay.
could.
Yeah. That feels not as overwhelming. Okay. Yeah.
Yeah.
Okay.
See, and that's the same thing with order of operation. So I could also order of operation. I like order of operation better than what they say PEMDAS, or BODAS, BOD. I think it's this
Is
way.
that acronyms?
These are more acronyms. I'm like, that's
I've
so
never
bad.
heard of that. I've never
Yeah.
heard of pen.
So
What does
PEMDAS,
PEMDAS?
parentheses, E is exponents. MD is multiplication and division. AS is addition,
And subtracting.
yep, and subtraction.
What's
So
S?
S, subtraction.
Oh yeah, there we go. Okay.
So this one is brackets. Brackets is the same thing as parentheses. Just depends on where you are in the country, where you are in the world. I forgot
Mhm.
O. I think maybe it's beddas because it's still O is E is still exponents. Beddas. I think it's beddas. Exponents. So the reason why I kind of stay away from the acronyms is because sometimes people are very adamant that you have to do multiplication first before the division. But I know order of operation. I know that if I do parentheses first, exponents second, third is a toss up. It can either be multiplication or division. And then the fourth is addition or subtraction. But some people are so set against that. No, you got to do division first before the multiplication. I'm like, why does that even matter? Because they're the same hierarchy. They're the same hierarchy.
Okay.
You know what I mean?
Yeah.
So I don't know why somebody thought of acronyms would be the best way, but I don't like acronyms because it doesn't help this situation.
So the order of operation would be first.
Yeah, first, second, third, fourth, right?
Okay. So you do
So
what's in the parentheses first,
yes,
and then the exponents.
yes,
Okay, there we go. Okay. Okay.
yeah.
There we go.
But again, I don't do acronyms because people get stuck how we say it. Like foil. First comes like in foil, right? First,
Yep.
inner, outer, whatever. So it doesn't make sense to me. I see it more like just the patterns, I guess.
Mhm.
So
Yeah,
okay.
makes sense.
But again, I'm excited for exponents because I was going to introduce it after the multiplication, but that won't be until like afterwards. But it's going to be like a 4 or 5 page. It's not going to be a separate book because there's no point.
Makes sense.
Yeah. So it'd be interesting to like even expand out to like say like the interest rate equation that I just showed you, PR. But then I would have to go into like algebra and stuff and see and kind of pick and choose what I can do and what I can't do in the abacus. Because at this point it's the concept, it's not arithmetic.
That's true.
So that's why I'm not sure if I'm going to go that route. If I have time, maybe I'll add it in, but I'm not sure if I would.
Yeah.
Because by here, you should be solid in your arithmetic that it should not be you should be able to just do this.
Mm-hmm.
But yeah, so you know what I mean? Like I think that's where I would probably would not go, but I would show it just to show how it's scalable.
Yeah, I would do that.
Yeah.
Thank you so much. This has been very helpful. I really enjoyed it. Yeah.
Yeah,
So
it's been great. It's been
had some aha
fantastic.
moments.
Yes, a lot of them, a lot of them. I have to review it and see where I can start like implementing and stuff. But that's the plan for the books in the path of the class. And so
Mhm.
it's different than what I have at the what I've been learning because I feel like it's more inclusive with the mainstream.
Mhm.
Yeah.
Makes sense.
Cool. Thank you so much.
Yeah,
Um,
thank you.
so I guess I'll see you next week.
Yes, yes. Thank you so much. I
Yeah,
really enjoy this.
yeah.
Thank you.
Yeah, so get your questions ready and your word problems and we can do more. We'll do more.
Okay, I will do that.
Okay, cool. Thank you.
Awesome. Thanks. Okay.
Okay.
Bye.
Bye.